Hello, today we're going to talk about solving radical equations. And these are just equations that have radicals in them. For our first one, we'll just go ahead and solve for x. And you can do this mostly in this problem just by looking at the problem. And you know what the square root of what equals 6. And so you know that x is going to be 36. But if we looked at this algebraically, what number, or what can we do to both sides of this equation algebraically to solve for x? And the answer here is to go ahead and square both sides. So remember, as long as I do it to both sides of the equation, I don't change the equation, and I don't change the value of x. So I know I can do it as long as I do it to both sides. So square both sides of the equation, and you get the square root of x squared is just x, and the square root of 6 is 36. So algebraically, you can solve that x does, in fact, equal 36. And one important thing to do with these types of problems when solving a radical equation is to go ahead and plug the answer you got back into the original problem to make sure that it does, in fact, work. Moving to the next slide here, I want you to take a look at all three of these equations and tell me which ones of them are going to have solutions. And you can do this either algebraically or just by looking at it. So go ahead and pause the video and let me know what you think about these three radical equations. Great, welcome back. Let's take a look at these three together. So the square root of x equals 3, you can square both sides or just look at it and know that x is going to be 9. And so you know that this one, in fact, does have a solution. So we'll put a check mark next to it. Looking at the next one, it's a little trickier because you have the negative sign outside and the negative 3. So you know, again, that if you square both sides here, you're going to get, again, that x equals 9. And you can plug that back in and look at the original problem. So the square root of 9 is 3. Negative 3 equals negative 3. So it does, in fact, have a solution. Now, looking at the last one here, if I square both sides, I'm going to find again that x equals 9. And I plug that back in because I need to do that every time I solve a radical equation just to make sure. And I can see that the square root of 9 is 3, and 3 does not equal negative 3. So this one does not have a solution. And you can also tell this just by looking at it because you know that the principal square root of something can't equal a negative number. So the original problem was square root of x equals negative 3, so you have a principal square root equaling a negative number, and you know that that can't happen. So looking at this screen here and these four problems, I want you to go ahead and solve all four of these problems for x, and go ahead and pause the video and come back to me when you're done. Great, welcome back. Let's take a look at the first problem. Square root of x equals 4. You don't need to do the math, but let's do it anyway. And we'll square both sides. And we're going to find that x equals 16. And you plug it back in and you find the square root of x the square root of 16 does in fact equal 4. So you know that x equals 16 is a correct answer. Moving to the next slide, now we get a little trickier because it's not just x in the denominator. So we're going to go ahead and square both sides. And we're going to get x minus 6 equals 9. And then we just solve for x. So 9 plus 6 gives us 15. And we plug that back in. I'm going to do that over here. So you got 15 minus 6 and the square root of that. So 15 minus 6 we know is 9. And so the square root of 9 is 3. And so we would get that the 3 equals 3. And so we know that x equals 15 works for this problem. Moving to the next one, we're going to square both sides again, just like we did in the last one. So we're going to get x plus 2 equals 49, or x equals 47. And we've got to plug that back in, and 47 plus 2 right? So we get the square root of 49, which is 7, and so therefore 7 would equal 7, so we know that x equals 47 is a solution. Looking at the last problem here of these four, we get the square root of x minus 4 equals negative 3. Now, looking at this, you can already tell that this should end up with no solution because there's a principal square root equaling a negative number. But let's take a look at it algebraically as well. And we'll square both sides, so we get x minus 4 equals 9, x equals 13. And we plug this back in, and we get the square root of 13 minus 4, and 13 minus 4 is 9, so the square root of 9, which is 3, and here you would get 3 equals negative 3, and you know that's not true, so you know 13 doesn't work, so there's no solution to this problem. Now we take a look at this and this problem here, and now the radical isn't alone on their side of the equation. So the first thing you have to do in this instance is to get that radical alone, just like the rest of us are during this quarantine. So just you want to quarantine that radical x minus 6 over here by itself by subtracting 4 from both sides. So you get it to x minus 6 equals 5. And now you can go ahead and square both sides like we were doing earlier. And you just solve for x, and you find that x equals 31. And now let's check our answer in the original problem. So we have 4 plus the square root of 31 minus 6, or 4 plus the square root of 25, or 4 plus 5, is 9, and 9 equals 9, so you know that x equals 31 is a solution to this problem. So remember, you just need to isolate that radical, or socially distance that radical from everything else. So use that information and that knowledge to go ahead and solve these four equations for x. So going ahead and looking at the first problem here, first thing we have to do is subtract 6 from both sides, and you get x plus 2 equals 6, and then we're going to square both sides, so you get x plus 2 equals 36, or x equals 34. And checking our answer, you have 6 plus the square root of 34 plus 2, or 6 plus the square root of 36. 6 plus 6 is 12, and 12 equals 12. So you know that x does in fact equal 34 is a solution. So looking at this problem here, the first thing we want to do is isolate that radical. And I don't have to isolate it. I can go ahead and square both sides with the 4 there, but now I'm squaring 32 and I've got a 16 left over that I've got to divide by later, where it's just easier to go ahead and get smaller numbers from the beginning. So when I divide both sides of this equation by 4, I get the square root of x minus 6 equals 8. And now I'm going to go ahead and square both sides, and I get x minus 6 equals 64, and I add 6 to both sides, and I get x equals 70. And then to check my work, I would have 4 times the square root of 70 minus 6, and that's going to be 4 times the square root of 64, which is 4 times 8, which does in fact equal 32. So then I know that x equals 70 is the solution to this problem. Here, right now you're looking at it and you're like, oh, that has a square root equal to a negative number, but you have to remember you have to wait until you've isolated that radical to make that determination, because when I add the 4 to both sides, I get the square root of x plus 7 equals 1. And now I have a principal square root equaling a positive number, so this can work. So I square both sides, and I get x plus 7, that looked a lot like a 2, equals 1, and then x equals negative 6. And now I check that answer, and I get the square root of negative 6 plus 7 minus 4. And negative 6 plus 7 is 1. So the square root of 1 minus 3, or minus 4. Sorry, I don't know why I wrote 3 there. So 1 minus 4 is negative 3. So x equals negative 6 does in fact work. And now here you've got two steps to go ahead and isolate that radical. And so we're going to go ahead and subtract the 3 from both sides. And then we're going to divide by the negative 6. And we get this. And right here you should stop. And you know that there's not going to be a value of x that can solve this. But if we were to keep going, if you didn't notice and you kept going, you would get x minus 4 equals 1 and x equals 5. And so we keep working here. I'm going to move x equals 5 up there just a little bit. And we check that answer, so we would get 3 minus 6 radical 5 minus 4. 3 minus 6 radical 1, 3 minus 6, negative 3. And so you can see negative 3 does not equal 9, and so you know that there's actually no solution to this problem. So it's important to always plug your work back in to make sure that you haven't mixed up an extraneous solution with an actual solution. So plug that value back in, just to make sure that x does in fact equal.